This particular question consists of a lot of electrochemical information and some redox changes are given, and we have to match the half reactions towards the potentials. So in which case we have to calculate the potential of every electrode given over there, or an equation given over there like this. For this, we have to use the data standard reaction potentials given. But the problem here is we have got iron plus 3 to be converted to iron. Iron plus 3 to be converted to iron takes 3 electrons, and the corresponding potential we have to calculate from the data given. And from the data given, we have got iron plus 3 plus electron giving iron plus 2. We have got E naught value 0.77 volts. If you convert it into thermodynamic data, like delta G naught would be minus NF E naught, would be minus 0.77 farads. Why should we convert electrochemical data into thermodynamic data? Because the potential is an intrinsic property. Delta G is an extrinsic property. And potentials cannot be multiplied just like that, and cannot be treated just like linear equations. And hence, we have to convert the electrochemical standard reaction potential into the corresponding Gibbs energy, and then we can perform linear operations like subtracting and addition, because delta Z is a state function as well as an extensive property. Therefore, the other equation involved would be iron plus 2 electrons giving iron. E naught is given as per this minus 0.44 volts, for which delta G naught would be, because 2 electrons are involved, as per minus the NF E naught is concerned, we get minus plus 0.88 farads. And adding up these two reactions, this iron plus 2, this iron plus 2 would get cancelled, and the net reaction would be iron plus 3 electrons would give iron, for which delta G naught can be given as 0.11 farads. But what is asked is reduction potential. So for this equation, the E naught can be given as delta G naught by minus NF. So you will be getting 0.11 farads by minus 10 of this equation is 3. F and F will get cancelled. You are getting 0.04 volts minus. It can be connected to third option. Coming to this particular equation, this is the mere non-redox equation. Still there will be a potential for this reaction also. For this particular reaction, potential can be derived from these two equations. If I write these two equations, because in this particular equation we have got H plus and OH on right side. If you rearrange these equations such that H plus and OH come on the right side and add up the potentials, we can get the potential of that particular reaction. So if I rewrite this, I get 2H2O gives 4H plus O2 plus 4 electrons. Because I have reversed, the potential also would be changing its sign, minus 1.23. And if I set this particular equation as is O2 plus 2H2O plus 4 electrons giving 4OH minus, whose potential is as it is, we have got 0.40 volts. And in adding up these two equations, O2 and O2 will get cancelled, and we are left with, after electrons get cancelled, 2H2O giving 4H plus 4OH minus. The potential is given as, adding up these two will get minus 0.83 volts. So this particular equation can be connected to minus P versus 3, Q versus 4. P versus 3, Q versus 4 is present in the D option. However, the other two can also be verified with the same redox calculations involving delta G, because as I told you, potential cannot be just like that added because it's an intrinsic property, and converting electrochemical equation into thermochemical equation, then perform all operations, required operation, get the required equation, get back the potential. Therefore, the correct option would be D.